All right, Dana, here is part 2 of your test. I just didn't want to make the other video too long, so let's see if we can get through this last 3 questions on this one. So for question 5, you started out correctly. You did a great job finding the vector equation for this line. And then you knew to take the cross product of the two direction vectors to get a vector perpendicular to this line, and so your cross product was 653. Good. So if you take your normal vector and you put it into this equation, and you get your scalar equation, then the only thing that went wrong here is with the point that you're substituting in. If you have 6x, then I'm assuming that you're putting in, I'm not sure which point you were putting in, because a is 1, 1, negative 2. That's the point. So that really should be the point that you're putting into your equation. It should look like this: 6 times 1 plus 5 times 1 plus 3 times negative 2 plus d equals 0. And then you have 6 plus 5 minus 6 plus d equals 0. So 5 plus d equals 0, and d should be minus 5 for that equation. Okay, so now that I've changed pages onto the last page for your assignment, it seems like there's something missing here because we didn't finish off question 5. And question 6 seems to be cut off at the top of the page here, so I'm having a little bit of difficulty there in terms of marking that, unfortunately. If you have the pages, if you could send them in, that would be great, and I'd still look at those and mark them for you, okay? So for question 7, you're being asked to find the intersection of these two planes. And I can see that you've lined them up here to subtract them. And I'm not clear on the work that you're doing in order to do that. If you start with the first plane, x minus 2y plus 3z minus 6. So there's a minus up here. Sorry, get my pen working here. Plus 3z minus 6 equals 0. And then we have 2x plus y plus z minus 7 equals 0. Okay. So if we add these up the way they are right now, you can't eliminate any of the variables. I'm not sure exactly what you're doing. I think you're multiplying everything by 2. Are you here in this case? So you'd get this and minus 12. So if we do 2x minus 2x, then we would get 0. And negative 4y plus y would give us negative 3. So I think that's what you've done, but you haven't shown the work where you've multiplied everything in the first equation by 2. You need to show that. And then we have 6z plus 1z should give us, oh, if we're subtracting 5z, okay. And then minus 12 minus negative 7 should be minus 5. Okay, so that's what you did. All right, so we have this, but that is not your line of intersection. That is just one equation in terms of two variables. So the next step here is to take z and assign it the value of t. So z becomes a parameter. And if you solve your equation now, you will have 3y equals negative 5t minus 5, or y equals negative 5t minus 5, all divided by 3. And then z equals t, and so both of these now have to be put back into one of the original two equations to solve for x. And then you will have all three variables, x, y, and z, defined in terms of the parameter t. So in other words, you'll have a parametric equation for the line of intersection for these two planes. So unfortunately, question 7 is not complete. And the last question that I have here is question 8. And you need to find the parametric equations of the line of intersection of these two planes. And so again, I need for you to show your work, please. If you're going to subtract or add to eliminate one of the variables. I'm not sure exactly what you're doing here. Let me just have a quick look so that I can understand. So you're solving for y in the first equation, and then did you do a substitution in the second equation? I'm not sure where y went. 3z minus, yes, you substituted, okay, I see what you did. So you've got y in terms of z, and then you substituted that into the second equation as 3z minus 1. Okay, good, you can do that. Now, minus 1 plus 4 is plus 3. Okay, so we got to the same point where we got to in the last question, but unfortunately that's not the answer. That's just part of the solution. So again, if we assign z as the parameter t, then in this case we would have, let's divide everything by 3 here, we would have x equals negative 3t minus 3. And then you can define y as 3t minus 1 and z as t. So your parametric equation for the line of intersection is made up of those 3 equations, and that's the parametric equation for the intersection of these planes, okay? So unfortunately, you have a bit more work to do on this topic. I would not recommend that you write the exam just yet. I'd like for you to go back and try all these questions again and make sure you have a really good understanding. There is also a practice exam posted in the content with some more questions like this, very similar to the ones that you'll be asked to answer on the final exam. And my suggestion would be that you work really hard on those and try them, and that you email me for some help if you can't get them, or ask the teachers there at your school to help you and show you how to do those before you do your exam. Okay?